Okay, so I've been thinking about our next steps, or what I want to look at next with you all, and I decided a good choice would be one of the other ink exams. So we looked at Flipper. Whoop, I hit the wrong thing. Flipper is very simple. So I said, we probably want to look at something a little more involved to understand how you write these smart contracts in ink. So I started looking at this is the GitHub for Paritytech, and they have a number of examples. And the one we're gonna look at is delegator. Delegator, what it does is it has a code that can either add or subtract, and then you have an accumulator, which keeps track of the totals. So you can think of it almost like, how you have a balance, like with a Bitcoin or something of that nature. So the delegated smart contract is our showcase for executing other smart contracts on chain. So tonight, I'm gonna break it up into two parts, and we're gonna start tonight looking at the delegator. The delegator is at the root, and it's librs, and what it so this is ink, this is Rust, using the ink language, and you create the module delegator. You're using the accumulator, which is how you're going to keep track, the adder, storage, and ink storage, and the subber, which is a subtractor. Now, let's see, specifies the state of the delegator and provides, I guess, derive. I'm actually not sure. Let me take a quick look here. Let's see what derive is. Derive is an attribute that allows new items to automatically be generated for data structures. It uses the meta list path syntax, specify the trait. So, let's see, to specify a list of traits to implement path to derive macros to process. So what's meta link path? Is syntax used okay, so they're talking about the syntax here. So that's what derive is. So what we're saying is we're going to automatically generate certain things. And two things that are interesting here are spread layout and path layout. So I looked up those definitions. Let's see. I thought I had it right here. Spread layout. Here we go. Spread layout. Types that can be loaded and stored to and loaded from the contract storage. And path layout is types that can be stored to and loaded from a single contract storage cell. So basically, one gives you a lot of space to put stuff, and one packs everything in. So we define two traits on ink storage, pack layout and spread layout. we create our storage and define the different attributes we're going to need. And then we define the structure for the delegator. So which the adder or subber is currently in use, the total value of the accumulator, the adder smart contract that essentially adds every time you touch it, every time you execute it. Subber subtracts every time you execute it, and then we implement the delegator. So this is our constructor here, the public function new, and we initiate a whole bunch of values, and this is going to return itself. It's going to return the delegator, if you will. Starts with a balance. There is a sort, kind of helps, for randomization. You set up the accumulator new with the init value. The init value is what you give it. The adder, you set that up. The subber, you set that up. And then you return what state it's in. You're returning it in the adder state with an accumulator, an adder, and a subber. And I believe lazy usually means, in everything I've seen, that it doesn't allocate things. It doesn't create your accumulator until it needs to. And of course you have your get, which returns the accumulator, and then you can change from adder to subber, and then let's see what. This is a call to either adder or subber. So depending on what it is, whether you're in adder mode or subber mode, it's either going to add or subtract. And this method says switch from the adder to the subber or vice versa, depending on which mode. So it's basically switch mode. So in essence, this is kind of similar to flipper. Now, what we are going to look at, I'm very curious. I think to understand this, I'm curious what the salt bites is. So let's look that up. Okay. Let's see. Okay, define. Is a salted password. Okay. The salted generated unit, which is a byte array randomly generated number. So, as I suspected, this has to do with random numbers. So I guess the endowment, the code hash, salt bytes, instantiate and expect. So if it failed, this is initializing some values, and we're going to take a look at this more tomorrow when we look at adder and subber, and this is telling to instantiate. So what we have after the constructor is we have all our pieces and parts, our accumulator, adder, and subber. It's returned by the constructor, the new function right here. And that is going to be our contract. And what we're going to end up doing when this is on the chain is we are going to be able to, we're going to run it, we're going to flip it and tell it to add or subtract a certain amount. And so it's kind of taking what Flipper did, but to a much more advanced level, because you have separate modules here not just one thing. You are also keeping track in this, and the so these are in essence 4 different smart contracts, 4 different libraries that are put on the chain. So what does it say here? Instantiate the delegator smart contract given all the code hashing. The smart contract will take over the work instantiating other smart contracts. So that's interesting. What we need to delve into more is, I'm curious, why are you instantiating with hashes? Except I can see the accumulator, maybe you want a random value. But there's obviously, this could be because you want the smart contract to have hash values in there. I suspect that's what we're talking about here. And we're not going to, let's just take a quick look at the accumulator just to see, can answer that question. So the only constructor, the only thing it stores is a value, and subber. Let's see if that gives us any more of a clue real quick. See, none of these directly pass any kind of random values in there. So my mission for tomorrow's video is to understand why or how this randomization, or why it's there, what we're doing with it. And but I think this should be an interesting example to play with and to put on our little chain there and see what happens. So hopefully this has whet your appetite for more, getting more in depth of this. And if you liked it, please give it a like. If you want to see more, then please subscribe, and I will speak to you tomorrow.